Since General Motors originally adopted the UNIMATE in the early 1960s, the automobile sector has been employing industrial robots for more than half a century. The number of robots utilized in the automation industry has increased dramatically in the interim. In addition, increasingly low-cost, flexible collaborative technologies have supplemented and replaced clunky and flexible classical robots. Automobile and automotive component manufacturers can use robots to increase productivity, lower costs, improve quality, and protect their people. Cobots, or collaborative robots, have opened up new options for automakers, such as the possibility to deploy robots in close proximity to human workers without the need for a fence. We will take a look at 6 examples of cobots or robots being used in the automotive sector below. But first, like, share, and subscribe to our channel. Let's begin. Let's first explain where industrial robots are used and what they do. There are relatively few industries that don't profit from automated processes. Countless additional companies and warehouses have implemented robot technologies since the first car robot joined the assembly line at GM. The pharmaceutical industry, general manufacturing, medical, and agriculture are all industries that use robots. Universal robots cobots are adaptable platforms that may be used for a range of functions in a variety of settings. Payload, safety compliance, and your ingenuity are the only limitations. Industrial robots in manufacturing can perform a wide range of tasks, including material handling, pick and place, and inspection, as well as assembly, packaging, and palletizing. Robots are programmed to carry out monotonous activities and relieve humans for physically demanding labor. Machine vision and artificial intelligence systems can be added to robots, allowing them to adapt to a range of scenarios and provide real-time feedback on system performance. Automobile manufacturers are now looking to using robotics in even more procedures. On these production lines, robots are more efficient, accurate, flexible, and dependable. The automobile sector has remained one of the most automated supply chains in the world, as well as one of the largest users of robots thanks to this technology. Every vehicle has hundreds of wires and parts, and getting them to where they need to be requires a complicated manufacturing procedure. Robots used in automotive industry. Now let's look at the 7 main applications for cobots in the automotive industry. Robots can do almost any physical duty involved in car production. There are also numerous chances for robots to assist with decision-making tasks, such as completing pass or fail quality inspections to verify that the end product is of sufficient quality. Number 1. Assembly. In many car manufacturing, including assembly, cobots play a vital role. Cobots can perform monotonous jobs in the assembly line, such as connecting door handles and windshield wipers, allowing humans to focus on higher-value duties. Larger, bulkier things such as wheels, hatches, and engine hoods can be handled by cobots with higher weights, such as the UR-16E with payload of 16 kilograms or 35.3 pounds. To assist in vehicle seat assembly, the Lear Corporation employs flexible, lightweight UR-5 cobots. The UR-5 has a compact footprint with 149 millimeters that allows it to work in tight locations, such as assisting with the assembly of vehicle seats and rest frames. The UR-5 completes an 8,500 times per day screw driving action at Lear, which has reduced the company's production time. Lear's first UR cobot was deployed in 2017. Currently, the business has 38 UR robots at its Chinese manufacturing facility, which are employed to conduct tasks such as car seat screw tightening, electrical inspection, pick and place, and other critical activities. Number 2. Painting. Painting robots have become a common feature of robot-assisted car manufacturing. No human worker can match the consistency and availability of robots when it comes to painting. Additionally, vehicle paint is poisonous, posing a significant risk to human employees. Robots are better at tasks like putting a precisely even coat of paint on a huge surface. Due to reduced wasted paint and the removal of human mistake, the precision and performance given by robots in painting activities decreases manufacturing costs over time. Number 3. Welding robots. Welding is another hazardous and time-consuming operation that cobots excel at. Arc, TIG, laser, MIG, ultrasonic, plasma, and spot welding, as well as soldering and brazing, are all possible using cobots. The UR Plus platform comes with everything you'll need to get started with your automobile welding application, including hardware and software. For example, the Olympus UR welding system is a low-cost welding option that's ideal for small automobile part producers. Number 4. Machine tending. One of the activities that's well-suited to collaborative robot-powered automation is machine tending. It's no wonder that machine tending has been one of the most popular uses for cobots in recent years. It's dull, often dirty, and occasionally dangerous. Bajaj Auto, based in India, is one of the world's major motorbike manufacturers and was the first to use cobots in the country. Bajaj Auto has since deployed 100 Cobots in its manufacturing sites to aid human workers with machine maintenance and assembly chores. This corporation wanted to improve the standardization and production speed of their two-wheeler vehicles. Number 5. Material removal and polishing robots. Material removal and part polishing are critical steps in the car manufacturing process. Cleaning up car parts along the route by trimming metal or polishing molds for smooth finishes is one of these steps. The activities, like many in vehicle manufacture, are repetitious and sometimes dangerous, making them a perfect candidate for robotic intervention. Grinding, deburring, milling, sanding, routing, and drilling are all examples of material removal tasks. For example, robotics finishing kits or hardware and software packages that include everything a maker needs to get started with surface finishing, sanding, and external tool finishing. The kits come with robotics finishing Copilot software, which is meant to make finishing applications simple to program, independent of the end user's level of robotics knowledge. Number 6. Quality inspection. Quality inspection techniques can be the difference between profitable production runs and costly, time-consuming failures. The automobile sector employs Cobots to assure product quality. Europe Plus offers a wide range of hardware and software to assist you in automating automobile quality inspection duties, such as cosmetic optical inspection and metrology. Comprehensive Logistics, an engine assembly company based in Ohio, has deployed a UR10 collaborative robot with a vision camera to assist with inspection activities. With the implementation, the contract manufacturer in Ohio was able to achieve 100% quality in the subassembly of car engines. Number 7. Robotic vision. Because it can see what it's doing, a light industrial robotic arm with eyes can conduct more precise work. The laser and camera array on the robot's wrist provide fast input to the machine. Because they know where a part goes, robots can now do proper offsetting when installing it. Robotic vision allows for more precise installation of door panels, windshields, and fenders than ordinary robot arms. Robots in car factories reduce part-to-part variability. They're highly repeatable because they never tire or become distracted, ensuring that each cycle is completed in the same manner. They also don't drop parts or handle them in a way that damages them. This cuts down on waste caused by human error, and it also decreases unpredictability in car assembly. Automotive robots with vision systems can even identify variations in arriving materials and adjust their preset courses accordingly. As a result, customer satisfaction is higher, there are fewer errors, and warranty costs are lower. To compensate for production delays, automotive supply networks are lean with little inventory. Every stage of the manufacturing line, automotive part makers aim for consistency in time and process control. An assembly line can be brought to a halt by the tiniest of issues. Because robots don't get tired towards the conclusion of a shift, cycle times are uniform all day, every day, and peak production rates are predictable. Furthermore, when compared to manually attended lines, running robots during breaks and shift changes provides more productivity from production lines. How does it protect workers? Many professions in the automotive industry are dangerous. The dangers are sometimes visible, whereas when pouring molten metal in the foundry. They can also be more subtle, such as musculoskeletal diseases caused by lifting, twisting, and repeated motions. These dangers to humans can be avoided by using robots. Robots in automobile assembly protect workers from welding and painting fumes, as well as weld flash and the noise of stamping presses. By removing workers from these filthy and dangerous duties and settings, automotive robotics reduces accidents and injury claims. Future of robots in the automotive industry. In the automotive production industry, there are numerous opportunities and applications for robots and collaborative robot intervention. Robots ensure higher quality, shorter manufacturing times, and fewer injuries on the job. Some of the most common robotics uses in the automotive industry are car assembly operations and parts producers. Robots are now easier to program and deploy than ever before, but each integration project presents its own set of problems. As a result, companies interested in implementing automotive robotics should hire an experienced integration partner to help with design and installation. To summarize, robots have been used in the automotive industry for a long time, and they're still utilized in a variety of ways today. Although the 7 applications listed above are some of the most popular, will the automotive industry completely become autonomous? What do you guys think? Let's know in the comments below. And with that, we come to the end of today's videos. If you enjoyed it, then don't forget to like, share, and subscribe to our channel. Thanks for watching.